Hi all, I'm Dr. N. Priyadarshini, Assistant Professor in Department of Physics. Up to this point, in your first year, you have studied how conventional energy material responds to stress, heat, electric field and light. Now we are moving one step beyond the syllabus to understand how material are designed at nanoscale. At this scale, the synthesis method play an important role in controlling the particle size, shape and morphology. That is, it also controls the overall property of the material, and after synthesis, suitable characterization technique is required to know. So in this video, you will learn how nanomaterial are prepared mainly, and you will be introduced to important characterization technique used to study the structure, composition and optical behavior and surface property. That's why today's video is about from bulk material to nanomaterial. See, before I go into one synthesis of material, so you have to know what is nanomaterial. When the dimension of the material are reduced to nanoscale, that is, its surface to volume ratio is significantly increased and it exhibits a different property from the bulk one. So therefore, engineer must understand not only about what the material is made up of, but you also know about how to synthesize it. So for synthesizing technique, it strongly influences the size and structure of the surface. So material is broadly here I classified into three types, three categories. So the first one is the ceramic or solid state method here. So first method is an ceramic or solid method. So in this process, the solid precursors such as metal oxides or carbonates are mixed and grounded and heated at high temperature. So the material can be sometimes pelletized or sintered. This type of method is very simple and it is used for prepare for bulk ceramics and some of mixed metal oxides. We need a high temperature and longer reaction time. The second category is the wet chemical method. Here the starting material is processed in a solution, that is for providing better homogeneity and high controlled over particle size. So here in this wet chemical categories, I categorize into seven steps. The first one is a salt gel. The salt gel, everybody know that the salt gel is a liquid salt is converted into one gel and dried and calcinated. The second method is the combustion synthesis. Here we use a metal salt, sometimes urea as a fuel or glycine as a fuel to produce an oxide powders, that is a for powder particle for rapid synthesis. Next one is a co-precipitation method. So here we use a different metal ions simultaneously precipitated from solution. So and we from the precipitation we get a nanomaterials. So and next method, fourth method is a hydrothermal synthesis. The crystalline occur inside in a sealed autoclave, that is at a very high temperature and pressure. So next is an electrochemical method. It is mainly used for controlled deposition of coatings. And next one is an ion exchange. Here the exchange of ions within an host or near to the material, and the intercalcination is also an insertion of ion or molecules into the layer of the host. So these sevens are belong to the wet chemical method. And next one is an next three step is broadly classified into thin film or vapor deposition method. It is a coating technique. So it is broadly classified into two types. One is a physical vapor deposition and other is a chemical vapor deposition. So in physical vapor deposition, the source material is physically vaporized and deposited on the substrate. So in chemical vapor deposition, gaseous precursor reacted with the reacted and it is deposited on the substrate. So that is a chemical vapor deposition. So all the three methods, ceramic or solid state or wet chemical or thin flame, we get a general outcome as an we get a powder, that is in the precipitated form, or nanoparticles or nanopowders, bulk ceramics. Sometimes the coating is in thin films. We get an output like this general outcome of the synthesis material. So in spite of all synthesis method, I today in this video I detailedly discuss about two method. One is a wet chemical synthesis type and other one is a physical vapor deposition. So here wet chemical synthesis is one of the most commonly used method for preparing powder particles or for fine powder or nanomaterials. So in this method, the starting materials are usually taken in the form of metal salts. Sometimes it dissolve in a suitable solvent. Usually we use a distilled water or DD water, double distilled water or ethanol to form a clear precursor solution. So this is the first step is the precursor solution preparation. The next step is a different solution that is mixed under the continuous stirring. So we can add an anionic solution or cationic solution. That is a different. That is a, we want to mix one two material, that is an nickel sulfide or some other zinc sulfide. We have to add, that is anionic and cationic. We have to mix. That is a mixing of solution. During this stage, we can use a reagent such as any precipitating agent or some chelating agent that may be added to the type of synthesis. What we synthesis or stirring ensures the uniform of mixing of ions. The third step is the reaction stage. Here, the chemical reactions takes place. That means that it required a starting material from the precipitate or sol or gel. That is important parameter. In this stage, we have to maintain an important parameter like pH, temperature, and concentration are to be controlled in the stage. So next comes to an aging. When mixture is kept undisturbed or mildly stirred for some times. So we given us some period of time for aging. So it helps to improve the homogeneity and crystallinity of the product. So after that, the product is separated and washed using a filter paper. That is what usually we done and what one filter paper or centrifuged. And after that, we have to washing. That is the washing removes the unwanted impurities or sometimes byproduct of your material. So then after that, you kept for an drying to remove the moisture. Usually the drying is done by the hotter oven. So the finally the dried material is calcinated at elevated temperature in the furnace. Why calcinated is important is here we remove the organic residues and improve the phase purity and crystallinity of the final material. So this is the way the wet chemical synthesis is simple and effective route to produce nanoparticles or powders or nanostructure materials with good control of size over composition and particle size. That is also maintained under the wet chemical synthesis method. Next one is an physical vapor deposition. All we know about an PVD. It is a vacuum based technique used to deposit at a very high, very thin layer of material or else we use a substrate. So the process is behind with an vacuum chamber. So the substrate is mounted on the holder. Here we have an holder shape. We mounted on the holder and air is removed from the chamber to create an high vacuum, to ensure the high vacuum. So these prevent the contamination and allow the vapor atom to travel without collision with the gas molecules. So the next is then high purity, that is in our target material or solid source or whatever. The target may be an metal alloys, oxide or sometimes nitride depending upon what type of coating we used. And third step is in vapor generation. This is an important step. So the thermal vapor is targeted, heated until it's evaporated. In sputtering, high energy ions are bombarded to the target and eject ion from the surface. So third step is important for physical vapor deposition. Next one is these vapor atom travel through the vacuum chamber towards the substrate. Since the chamber pressure is very low, the atom move with a fewer collision and reaches the substrate effectively. So that's why the next step is then deposition on substrate. So when vapor species reaches to the cooler substrate, they condense on its surface. Initially small nuclei are formed. These nuclei grow and combine to produce a continuous thin film. So next step is in film growth and control. So the film thickness and the property can be controlled here. because we adjusting the deposition rate, time and pressure, or substrate temperature, sometimes an input power to control the thickness. So after deposition, the coated substrate is allowed to cool. Why? Because we remove that is, we produce a thin uniform layer. So it is widely used for cutting tools, or we have to use for semiconductor device, solar cells, or this thin film may be used in the optical coating, or some time of wear resistant surfaces we use these type of deposition. Next one is, after synthesis, we all know the next important process is an characterization. Why we characterization important? It is help us to understand the structure, composition and property and surface nature of the material what we prepared. So first one is an XRD. Everybody know that XRD means X-ray diffraction. It is used to identify crystal structure and phase of the nanomaterial. It also helps us to estimate the crystalline size and confirm whether the desired material is formed or not. So first primarily study is XRD. Then next one is an FTIR, that is Fourier transform infrared spectroscopy, is usually identify the functional group and chemical bonding present in the sample. So it helps us to understand the presence of metal bonds or metal oxygen bonds, OH bond, or any other organic species residues are present. So that type of characterization is get it, that type of information is get it from FTR. Next one, UV visible spectroscopy is used to study the optical absorption behavior. So from this one can determine the absorption end and edge and band gap. So band gap is so important. And next one is an PL, that is photoluminescence spectroscopy. It gives the information about the emission property of the material. So why we used one who studying the defects or recombination of charge carriers or luminance behavior, we study the PL, photoluminescence. Next one is an electron microscopy, that is here SEM, scanning electron microscopy, TEM, transmission electron microscopy, both used to observe the surface morphology, particle size and agglomeration of the particle. So it give an very TEM give an internal information, that is with very high resolution. So finally we go for an XPS. XPS means X-ray photo electron spectroscopy. So this is used to analyze the surface chemical composition. What are the chemicals are in the surface, and the oxidation state, that is in a 2 plus state or 3 plus state, that the oxidation state one can know by the XPS and confirming the chemical environment of the material surface. So these characteristics technique give a complete understanding of your nanomaterials. Thank you.